Hello guys, welcome to Knit classes. This is the third part of the Trigonometry chapter of class 10 maths book Ncert. If you have not watched the earlier parts, I would suggest you to just go and watch the first two parts of this video. But if you know basics of trigonometry, you can just simply continue with this video. This is the solution of the first exercise of the trigonometry chapter 8.1. So the first problem is, in triangle ABC, which is right angle at B, the length of AB is 24 cm, BC is 7 cm, and we have to determine the sine of A, cos of A, sine of C, and cos of C. So the first thing that we do in any trigonometric problem is try to draw the diagram of the triangle. So since the right angle is at angle B, so we draw a right angle triangle whose right angle is at angle B. And we name the other two sides as A and C. And we can write this as C or even this as C. Here I have taken this as A and this as C, and the right angle this as B. So the AB is 24 cm and BC is 7 cm. We have to determine the length of the side, the third side or the hypotenuse AC, which can be easily determined using the Pythagoras Theorem in this triangle. So AC square is equal to AB square plus BC square, which we get from the Pythagoras Theorem, and then AB is equal to 24, BC is 7. So just by simple calculation we find that AC squared is equal to 625, and thus we get AC as root over 625 or just 25 centimeter. Now the next step is to determine the trigonometric ratios. So the sine of A. So sine of A is from the line which I have taught. If you have not seen the previous video, just go and see the sentence which I have given to just write all the trigonometric ratios. Some people have curly black hairs turned permanently brown. We can use this sentence to determine all these trigonometric ratios. So the first one is sine of angle A. From the line we get it. Some people have it is perpendicular by hypotenuse, and we know perpendicular is the side opposite to angle which is given. That is, here the angle is A, so the perpendicular will be the side opposite to angle A, and hypotenuse is the same. And the side opposite to angle A we get from the diagram is BC, and hypotenuse is AC, so we get BC by AC as 7 by 25. Next is cos of A, which we get curly black here, that is base by hypotenuse. Now base is nothing but the side adjacent to angle A, and the hypotenuse is same in any triangle. The side adjacent to angle A is AB and the hypotenuse is AC, so we get cos A as 24 by 25. And next is sine of C. Now we see that this is the sine, and the perpendicular, the sine is nothing but perpendicular by hypotenuse. Now the perpendicular is the side opposite to angle C. The side opposite to angle C here is AB. So it is AB and hypotenuse is AC. And in cos C again, it is curly black here. It is base by hypotenuse, and base is the side adjacent to angle C. The side adjacent to angle C is BC, and the hypotenuse is AC, and BC by AC is equal to 7 by 25. So this is the first problem. Hope you guys are cleared with this. So the next problem here is, it is given in the figure 8.13. A triangle is given and two sides are given, and the PQ is given as 12 cm and PR is given as 13 cm, and we are to calculate the value of tan of P minus cot of R. So we no need to do a diagram, as the diagram is already given in the question. We just determine the third side, the remaining side which is not given, that is QR. So which can be easily determined by the Pythagoras Theorem. So from the triangle PQR, if we apply the Pythagoras Theorem, we get hypotenuse square, that is PR square, is equal to sum of the squares of the base and the perpendicular, that is PQ square plus QR square. And from there we find the value of QR square as PR square minus PQ square, and PR square is PR as given 13, that 13 square minus as PQ is as 12, we had 13 square minus 12 square, and by calculation we find that QR square is equal to 25, and so QR is equal to 5 centimeter. Now we have to determine the value of tan P and cot R. Now the tan P is from the sentence turn permanently brown. So it is perpendicular by base, and perpendicular is nothing but the side opposite to angle P, and base is nothing but the side adjacent to angle P. So the side opposite to angle P is QR, and this QR, and the side adjacent to angle P is PQ. So tan P is equal to QR by PQ, and it is its value is 5 by 12. Now next is cot of R. We know that cot of R is nothing but the reciprocal of tan of R. So tan of R is equal to perpendicular by base. So 1 by P of B is P by B. It becomes the base goes here up to the numerator and becomes B by P. It is the B means base and P means perpendicular. Don't get confused with this P and this P. This B only means base, and this means the perpendicular. So the base means the side adjacent to angle R. You don't get confused with this P and this B and this B. This base is related to this angle, and this base is related to this angle. So the base adjacent to the side adjacent to angle R will be the base for this problem, and the side adjacent to angle P will be the base for this trigonometric ratio. So we find side adjacent to angle R is QR, and the side opposite to angle R is PQ. So we get cot R as QR by PQ, and which ultimately leads to 5 by 12. So we find the value of tan P minus cot R as 5 by 12 minus 5 by 12, which is 0. So the next problem is, if sine of A is equal to 3 by 4, then we have to calculate the values of cos A and tan A. So we first draw the diagram. We take the angle A as a base, so we draw it below here, not here, for the sake of our convenience. Then since it is given that sine of angle A is 3 by 4, we take the trigonometric ratio of sine of A as perpendicular by hypotenuse, which is equal to 3 by 4. Then the side then based on angle A, the perpendicular will be BC and the hypotenuse will be AC. So it becomes BC by AC is equal to 3 by 4. Then we take BC as 3K. Then obviously AC becomes 4K. And applying the Pythagoras theorem in this triangle, we get AC square is equal to BC square plus AB square. We put the value of AC and BC and calculate AB square as 16K square minus 9K square, ultimately which is equal to 7K square, and thus we get the value of AB as root over 7K. Then we calculate the values of cos A and tan A by this. The cos A is base by hypotenuse, which becomes ultimately AB by AC, and the value of AB and AC are root over 7K and 4K. So we get the ratio of cos A as root over 7 by 4. And similarly for tan of A, we get perpendicular by base, curly black here turned permanently brown. I hope you remember that. Then the perpendicular by base becomes BC by AB, BC by AB the perpendicular base, and which ultimately becomes 3K by root 7K, and thus it becomes 3 by root 7. Let's then move to the next problem, which is given 15 cot of A is equal to 8, and we have to find the values of sine of angle A and sec of angle A, which is very similar to the previous problem. We draw a triangle, put angle A here, and we find that 15 cot A is equal to 8, and we thus get the value of cot A as 8 by 15. And as we know, the value of cot A is nothing but the reciprocal of tan of A. So we put cot A as 1 by tan A, and thus get the value of tan A as 15 by 8. Then as we know, tan A is nothing but perpendicular by base, and thus we get BC by AB is equal to 15 by 8, and we take BC as 15k, and thus AB becomes 8k. And similarly, we apply Pythagoras theorem in this triangle and thus get the value of AC square as AB square plus BC square. We put the value of AB and BC here, AB as 8k and BC as 15k, and get the value of AC square as 289k square, which ultimately leads us to AC as 17k. Now we determine these two trigonometric ratios, sin A and sec A. Sin A is the ratio of perpendicular by hypotenuse. The perpendicular is BC and the hypotenuse is AC. So we get 15k by 17k, which is 15 by 17. And the next ratio is sec A, which is the reciprocal of cos of A. And cos of A is base by hypotenuse, curly black here. And this hypotenuse goes up, so it becomes sec of A becomes hypotenuse by base, and the hypotenuse is AC and the base is AB. And we get AC by AB as 17k by 8k, which gives us the value 17 by 18. Now the problem 5 and 6 are just similar to the examples which I have done in the previous video. The example 1 is referred with question number 5, and example 2 is quite similar with question number 6. I hope you guys can do this to some. So I think you won't face any difficulties in solving this two problem. If you face any difficulty, please write down in the comment section. I will give the solution of these two problems as well. Now the next problem is a very important one. It is given here that cot of A is equal to 7 by 8, and we have to evaluate the values of 1 plus sin A, 1 minus sin A divided by 1 plus cos theta by 1 minus cos theta. Remember, this sign is called theta. This is a Greek alphabet which is called as theta. As we take x variable for numbers, we take theta variable generally for the angles. In this, so first of all, we draw a triangle ABC, and we assume that this theta is nothing but angle A for the sake of our convenience. Now in triangle ABC, cot of theta is given as 7 by 8, and we know cot theta is the reciprocal of 1 by tan theta. So we get tan theta as 8 by 7, and we know tan theta is equal to perpendicular by base. So we get BC by AB as 8 by 7, and we can take BC as 8k and AB as 7k. Now we apply Pythagoras theorem to this triangle ABC, and we get the value of AC square as AB square plus BC square, and simple calculation lead us to AC is equal to root over 113k. You can just follow up this simple calculation. These are not so tough. Now we calculate, since we have to determine the values of 1 plus sin theta, 1 minus sin theta, and 1 plus cos theta and 1 minus cos theta, it is just sufficient to calculate the values of sin theta and cos theta. We don't need any other trigonometric ratio in this problem. So we calculate sin theta and cos theta as sin theta is equal to perpendicular by hypotenuse, which give us BC by AC and 8k by root 113k, which give us this value, and cos theta we get as base by hypotenuse. Same from the sentence, some people have curly black hairs. We get cos theta as 7 by root 113, like AB by AC, base is AB and AC is the hypotenuse. Now we calculate this value, 1 plus sin theta into 1 minus sin theta, 1 plus cos theta and 1 minus cos theta. We just simply put the values of sin theta and cos theta in this term, and we get 1 plus 8 by this, 1 minus this, 1 plus this and 1 minus this. And we use the simple algebraic identity, a plus b into a minus b is equal to a square minus b square. I hope you know this simple identity. Then we see that 1 square is 1 and 8 square is 64, and root over 113 square is nothing but 113 itself. Then from the denominator also we get 1 minus 49 by 113, and then we solve it We take the LCM 113 and it becomes 113 minus 64. Again 113 in the LCM and it becomes 113 minus 49, and ultimately we get the value 49 by 64. This is the step, and the next value which we need to determine is cos square theta. Cos square theta is you don't get confused as this is square for only square cot, not for theta. This term cot square theta means the cot square is squared as whole, not only cot. The cot square and the cot theta is squared as a whole. So cot square theta is nothing but the cot theta whole square, and the value of cot theta is given in the question itself as 7 by 8. So we just simply put the value of cot theta as 7 by 8 and we get cot square theta as 49 by 64. Now the next problem is if 3 thrice of cot A is equal to 4, and then we have to check this equation, that is 1 minus tan square theta divided by 1 plus tan square theta is equal to cos square theta minus sin square cos square A minus sin square A or not. So we begin the problem by drawing the simple diagram. We take the angle A here for the sake of our convenience, and we solve this given equation, that is 3 of cot A is equal to 4. We see that we find cot A is equal to 4 by 3, and cot A is nothing but the reciprocal of 1 by tan A, the reciprocal of tan A, and so it becomes cot A is equal to 1 by tan A, and we get tan A as 3 by 4, and tan A is nothing but perpendicular by base. The perpendicular here is BC and the base is AB. So we can take BC as 3K and AB as 4K, and then we apply the Pythagoras theorem in this triangle to determine the value of AC. So we get the value of AC square as AB square plus BC square. We put the values of AB and BC as 4K and 3K, and hence we, by simple calculation, we find the value of AC to be 5K. Then we determine the value of sin A and cos A. We don't determine the value of tan A again, because in this step we have already determined the value of tan A. So we don't need this value. All we need is a value of cos A and sin A. So we determine the value of sin A by sin A is perpendicular by hypotenuse. So the perpendicular is BC and the hypotenuse is AC. So we get sin of A as 3 by 5 and cos of A as 4 by K. Cos of A is base by hypotenuse. Some people have curly black here. I hope you guys have by hearted this simple sentence. So now we determine the value of the left hand side, which is 1 minus tan square theta, tan square A divided by 1 plus tan square A. Now 1 minus tan square A. Tan square A is simply again nothing but the square of the term tan A. So we write tan square A as tan A whole square and in the denominator as well, and we put the value of tan A as 3 by 4, which we have got from this line. 3 by tan A as 3 by 4. We just simply substitute it in this and solve this to get the value of 1 minus tan square A by 1 plus tan square A as 7 by 15. If you find any difficulty in solving this, you can just solve it by your own way, or you can just pause the video and write these steps. The right hand side of the equation is solved as cos square A minus sin square A. Now cos square A is nothing but the square of the term cos A, and sin square A is the square of the term sin A. We put the value of cos A and sin A, which we have determined here, sin A to be 3 by 5 and cos A to be 4 by 5. So we get the value of cos square A minus sin square A to be 16 by 25 minus 9 by 25, which lead us to 7 by 25. So we see that these two values are to be same. So hence we can say that these two values are also same. Hence we can write 1 minus tan square A divided by 1 plus tan square A is equal to cos square A minus sin square A. I have not done the example, the question number 9. That is very easy, and I hope you guys can easily solve that. But still, if you have any problem in solving that problem, you can just write in the comment section. I will help you with that problem also. So we move on to the next problem, question number 10, which is in triangle PQR, which is right angled at Q. It is given that the sum of PR and QR to be 25 centimeter, and the length of PQ is given to be 5 centimeter, and we have to determine the value of sin P, cos P, and tan P. So we write the given part, and we just simply apply the Pythagoras theorem in this triangle. So in triangle PQR, if you apply the Pythagoras theorem, we get PR square is equal to RQ square plus PQ square, and from this equation we find the value of PR to be 25 minus QR, or RQ the same thing. We put it in place of PR and solve this. We solve 25 minus RQ whole square as A square minus twice AB plus B square, and we keep we put the value of PQ to be 5, and then keep this value as same, 5 square 25, and we see that RQ square from LHS and RHS get cancelled out, and all we remain with 625 minus 50 RQ is equal to 25. We take this here and this here and get 600 is equal to 50 RQ, and get the value of RQ to be 600 by 50, which comes out to be 12 centimeter. And thus we get the value of PR from this equation, which is 25 minus RQ, which gives PR as 13 centimeter. Now we calculate the values of sin P, cos P, and tan P. Sin P is nothing but perpendicular by hypotenuse, cos P is base by hypotenuse, and tan P is perpendicular by base. So we get this values easily from this diagram. Not diagram, but from PR is 13, RQ is 12, and PQ is 5. We just put the values here, and we get sin P is 12 by 13, cos P is 5 by 13, and tan P is 12 by 5. So the last problem of this exercise is question number 11, which is nothing but simply true or false, and here we have to justify our answer. The first problem is the value of tan A is always less than 1. So it is false, and how it is false I will explain here. We know that tan of A is equal to perpendicular by base, and if the value of perpendicular is greater than the base, for example, suppose if in this case perpendicular is 7 and the base is 6, then this value is obviously greater than 1. Alright, so if perpendicular is base greater than base, then the value of tan A is always greater than 1. So our question which is given the value of tan A is always less than 1 is false. The next is sec of A is equal to 12 by 5 for some value of angle A. Now we see that sec of A is equal to 1 by cos A, and cos A is base by hypotenuse. The hypotenuse goes up and becomes hypotenuse by base, and as we all know the hypotenuse is the longer side, so it is obviously greater than the base, and we see that 12 is greater than 5. So the value of sec A can be 12 by 5 because hypotenuse is always greater than the base. The next question is cos A is the abbreviation used for the cosecant of angle A, and as I have discussed in the first video of this chapter, cosecant stands for cosec A and cosine stands for cos. So this statement is false because cos of A is nothing but the abbreviation used for cosine of angle A, not cosecant of angle A. Cosecant of angle A is used for cosec A. Now the next problem is cot of A is a product of cot and A. So this is a main misconception of the student. They simply find that cot of A means the product of cot and A. This is not the case. Cot of A is a trigonometric ratio, and which is abbreviated for the word cotangent of angle A. Now the last true and false of this exercise is sin of theta is equal to 4 by 3 for some angle theta, which is false, as we know that sin theta is equal nothing but the ratio of perpendicular by hypotenuse. So the value of sine theta must be always such that the value of the denominator must be greater, since the hypotenuse is greater than the perpendicular. So in this case we see that the denominator is less than the numerator. So this can't be the case for sine theta, because the hypotenuse or the denominator must be greater than the numerator. So the sine theta can't have the value 4/3. In the next exercise we will find the ranges for different trigonometric ratios. So with this our first exercise is completed, and the remaining part of the chapter is taught in the next class, next videos.